Hello friends, welcome to engineering tutorial. So today we are going to start a new topic, a new subject, uh, which is the foundation or the basic concepts related to the semiconductor devices. Okay, the name of this subject is physics of semiconductor devices. Now why this subject is very important is that the electronic industry and all the subjects that are related to electronics, they are based on semiconductors. Okay, the entire electronic industry is based on semiconductors. So it is very important to understand the basic functioning, the principles of operation of these semiconductor devices. Okay, so be it basic electronics, be it optoelectronics, be it VLSI or any other field, semiconductors come into play, and to understand the basic principle, the functioning, the working, we need to have a good understanding about the physics of the semiconductor devices. So that's what this whole subject is all about. Okay, so this is just a basic introduction to the physics of semiconductor devices. So let's get started. So the semiconductor physics, as I said, the whole electronic industry is based on semiconductors. So this semiconductor physics subject is about understanding the various aspects of the semiconductor devices. Okay, so how to study, what are the main elements of the semiconductor materials or the semiconductor devices that we'll be using. So we can study this whole subject and can divide it into three main parts or three ways in which we can study it. So first will be the basic electronics. Okay, the basic electronics here means the various semiconductor devices that are normally used, be it diodes, be it bipolar junction transistors, BJT, field effect transistors, which can be JFET, junction field effect transistors, or MOSFET, metal oxide semiconductor field effect transistors, so whatever semiconductor devices that are used, we will categorize them or we will study them from that point of view. So we'll divide one section with diodes, one with BJT, PN junction diodes, then with BJT, field effect transistors. Then we'll study the concepts of solid state physics that are applied for that device. And then the quantum mechanics concept will come into play, because the quantum mechanics deals with the mechanics of subatomic particles. Now we all know that the electrical conductivity in semiconductors is because of electrons and holes. So in order to understand their movement, the various phenomena associated with it, we need quantum mechanics, not classical mechanics. Classical mechanics is not applicable for that. We have to use some of the concepts of quantum mechanics. It can be the uncertainty principle, it can be the energy quanta principle, it can be the de Broglie principle, so whatever, we will discuss that. So next, all this discussion around semiconductors. So what are semiconductors? Now we all know that the semiconductors are materials which have conductivities lying in between that of conductors, pure conductors, mainly metals, and insulators. So the conductivity of semiconductors is lesser than that of metals, but more as compared to the insulators, and they are found in column 4 of the periodic table and the neighboring columns. So the commonly used, the popular semiconductors that are used are silicon, germanium, and other compound semiconductors are also used, such as gallium arsenide, gallium phosphide, and other semiconductors. Will come to that. So the semiconductors, the special property is that they have conductivity lying in between the metals and the insulators. Now, the classification of semiconductors. Now, if we want to categorize semiconductors into two broad categories, they will fall into two categories. First one is the elemental semiconductor materials. The second one is the compound semiconductor materials. So first is the elemental semiconductor materials. So the elemental semiconductors, they are composed of a single species of atoms, okay, one type of atoms. Most commonly used elemental semiconductors, the popular ones, are silicon and germanium, and mostly silicon is used in the electronic industry. It is the most popular choice. There are various reasons for it. We'll discuss it in a separate video. For now, you just understand that silicon is the most commonly used elemental semiconductor, perhaps the most popular semiconductors. Then is the compound semiconductors. Now, as the name suggests, the compound semiconductors are made from combinations of elements, especially from the group 3 and group 5 elements of the periodic table. And the examples of common compound semiconductors that are there are aluminum phosphide, aluminum arsenide, gallium phosphide, gallium arsenide, etc. So these are the commonly used compound semiconductors. Okay. Now, why do we use semiconductors? What is that unique property that semiconductors have, for which they have cemented their place in the electronic industry? Why not conductors? Why not insulators? Why not the metals that are used? Why not any other insulator such as plastic, wood, glass, whatever? Why only semiconductors are used? So that is a very interesting question. Okay, now we all know that the semiconductors, they have conductivities lying in between that of metals and insulators. Okay, but one interesting property which the semiconductors have is that this conductivity of semiconductors can be varied to a great extent by making certain changes in the surrounding parameters, the environmental parameters, whatever in the environment in which that semiconductor device is placed. For example, by making certain changes to the temperature, the conductivity of the semiconductors can be varied. By focusing light of a particular frequency or wavelength on the semiconductors, which is called as optical excitation, the semiconductor conductivity can be varied. By changing the impurity concentration by the process of doping, okay, in which we add some impurity, some external atoms, and by that the conductivity of the semiconductors can be altered or changed. So this is the reason why the semiconductors are popular in the electronic industry, because of this property of change in conductivity with the help of suitable changes in various parameters such as temperature, optical excitation, and addition of impurity by the process of doping. So we will be discussing about all these things in detail, but here in this first video I just wanted to make you understand about the various basic concepts related to physics of semiconductor devices, this subject, what are the various aspects of it in which we are going to study. So this is the main thing, that the elements of semiconductor physics, it's all about the basic electronics, the solid state physics aspect of those devices such as diode, PN junction diode, BJT, FET, whatever the device that we are going to discuss, and then we'll use the concepts of quantum mechanics to understand the operation, the design in a better way. So here we have discussed some basic concepts related to the semiconductor physics basic concepts related to that. So in the next videos we'll discuss some more concepts related to it. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.